Hello everybody, I am Cătălin Tudose. I am a Manning author. I have written the book called JUnit in Action, and I am currently preparing a new book about Java persistence. Today we are going to discuss about object-relational mapping using JPA, Hibernate and Spring Data JPA. So let's dive into these topics. First of all, to introduce to you the objectives of our session. You will find out about the fundamentals of object-relational mapping, about the basics of JPA, Hibernate, and Spring Data JPA, and by the end of our session we are going to make some comparison between the work with JPA, with pure Hibernate, and with Spring Data JPA. If you ask yourself if it is the right place to be, I would say definitely yes, but if you would like to check again, we would like mostly to target developers who are new to ORM, or even if you are not new to ORM, if you have some understanding of ORM and want to choose between different alternatives, it is the right place to be, because we are going to make some comparison between these alternatives. To introduce what or to remind to you what object-relational mapping is, we talk about object persistence. If we have an application and we execute it, there are many situations when we would like that the information from the objects in the memory to survive the end of the execution of that application. And this is object persistence. We would like to save the information from these objects, most likely to a database. And we have a few possibilities to do this. We can use pure SQL, stored procedures, and triggers, so to address directly to the database. Or from a Java application, we may use the classical JDBC API that is in use for many years in order to access databases from Java. Or we may use some ORM or object-relational mapping implementation. For example, Hibernate, which is definitely the most popular ORM implementation. And today a very hot technology is available. It is called Spring Data, and it facilitates the access to different kinds of data stores. JPA, formerly Java Persistence API, nowadays Jakarta Persistence API, is a specification. Not an implementation, but it is a specification that tells us what needs to be done and which API is available in order to persist your objects. Of course, behind the JPA specification, you need a persistence provider that will effectively implement the object-relational mapping. Hibernate, for example. But JPA has its own API, it provides it to us, and we are free to use from a few alternatives as a persistence provider. Hibernate as a persistence provider may be used together with the JPA API, but at the same time it has its own native proprietary API. It is an independent framework, but it also can be used together with other frameworks, for example with Spring, but also with Jakarta Enterprise Edition. And Spring Data JPA, which is a layer that comes on top of these ones. It provides some improved support for JPA-based data access layers. We are going to demonstrate that it reduces the boilerplate code, and it creates some implementations for the repository interfaces. Now that we introduced our topics, let's have a look at the code demonstration. I prepared here an application that would like to persist information using Hibernate, using JPA, and using Spring Data JPA. So let's see what it provides to us. We have a class called entity, and in order to show that it is related to a database, it is annotated with this entity annotation. This tells that it is not just a simple class, but it has some correspondent table into the database. It needs to have some identifier, some ID that corresponds to the primary key in the database. And that is why this ID field is annotated with ID. And we tell here, hey, generate this value. Who? The database should generate this value using this identity strategy. Otherwise, it provides some simple info, and for it, we have here a getter and a setter. So this is our entity. It is simple, and we would like to persist it. We would like to compare our alternatives for persistence and to conclude about which are the advantages and which are the shortcomings of each of them. So what can we do with this item? We can try to persist it with JPA. And I prepared here some piece of code. It is a test that will persist this item. We are using this JPA API. In order to work with JPA, we need some persistence information or persistence metadata, and it belongs here into this persistence.xml file. What are we telling here? Among others, that our persistence provider is Hibernate. So our JPA is backed by the Hibernate implementation. And we provide here a few informations about accessing the database. I installed here on my machine the MySQL database, so I provide here the information about the driver, that it is the MySQL driver. The URL of the database to be accessed is this one, just to let you know that MySQL is running on port 3306. The name of the database that I created is Twitch, and in order to access it, we provide this user and password, no password, user root and no password. We are addressing to a MySQL database, so I have to write here that the dialect is MySQL dialect. This means that whenever you will try to persist an entity, Hibernate will translate the persistence action into some insert query, for example, that will use this MySQL dialect. So you will not have to care about which database you are using. You just have to provide the correct persistence information here, and Hibernate will take care about the generation of the SQL queries. In case you would like to switch to another database, you have to change this configuration, and for the consistency and in order to demonstrate how it works, I provided here some example inside the command saying if you would like to move to H2, let's see, you have to change here the driver, the URL, user, password, and dialect. And for the moment, I do not show the SQL when it is generated, but whenever I will execute my my queries, I will create the tables from the scratch. So this is the meta information that JPA needs in order to work with the database. What does it do? The JPA API used here will need first to create an entity manager factory. Based on it, we'll create an entity manager. It will begin a transaction, create this item, persist it, and commit the transaction. And if we would like to ask ourselves what's inside the database, did we correctly persist the information, we can address to the database using the same API. Say, hey, please create this query to select everything from item, and let's have a look at it, what's here into this items list. And in order to make sure that everything is right, I'm also asserting here that the size of the items that I retrieved from the database is 1, and the content of the item that is retrieved is correct. Let me execute this test. Just a moment. It says save retrieve item. It says it is correct. Test is green. And if we go here and I take a look at the content of the database, I see I have this item from JPA. If we would like to see more about how things are going, I can go here and choose to show the SQL while it is generated, re-execute this, and you see that we have the possibility to inspect what Hibernate creates for us. So it creates a table because here I instructed it to create a table at each execution from scratch, and it will insert this information. So we have the possibility to inspect. Of course, the SQL is generated according to this MySQL 8 dialect. So this is the JPA API. We have the possibility to use the same item as an entity, but to save and retrieve it using the Hibernate API. In order to do this, I also need some configuration, some metadata about configuration. Things are pretty similar in concept, about the driver, about the name of the database, username and password, and some information about the pool size of connections to be maintained. Show SQL, let me commute it to true. And again, I am creating the database, the table from the scratch. And if I execute this test, just a moment. We see again the generated SQL, dropping the table, recreating it, inserting information. And if I go here, it was item from JPA, I re-execute it. So now I have item from Hibernate because I recreated this item using the Hibernate API. So I go back here, and you will see that the steps of the execution are pretty similar. First, we have to create such a session factory based on the configuration that is provided here. This hibernate.cfg.xml file is the default name of the Hibernate configuration. So it will take the configuration from there, add item as an annotated class, build some configuration, and build this session factory that is used here. Then we create the session, create the item, persist, commit the transaction, and create another transaction to retrieve the item from the database. Pretty similar steps and a different API. So the JPA API and the Hibernate API are having some similarities, but they are different APIs. Can we commute between Hibernate and JPA? Let's presume that we have some JPA application and we would like to commute it to Hibernate or vice versa. Yes, we have some possibilities to obtain an entity manager factory from a session factory and vice versa. And I prepared here this example. When we commute from Hibernate to JPA, meaning that we have some session. Yes, we have some configuration here from Hibernate, and we would like to build an entity manager factory based on it. Here we load this configuration from this default Hibernate CFG XML file, and we take property by property, we populate these properties variable, and we pass it as an argument of this create entity manager factory. So we have a Hibernate configuration, but we use this small method and this small piece of code in order to create some entity manager factory. So we have Hibernate configuration here, and we create an entity manager factory based on the properties on this Hibernate configuration. You see, I'm retrieving here entity manager factory, and then I am able to use this entity manager factory just like if it was obtained based on a persistence.xml configuration. Let me try just to execute this. We see again the creation of the table and the insertion of the information. And if I go here and I say select all from item, I say item from Hibernate to JPA, we provided different information just to emphasize that we are doing different things. And vice versa, from JPA to Hibernate. Let me close these ones. I have here this test. I have an entity manager factory which is a JPA object, and as long as I know that it is JPA is backed by Hibernate, I can simply unwrap this session factory and to obtain from this entity manager factory this session factory. And from here, after that I unwrapped it, I can start using this session factory and the Hibernate API just like I was previously doing. Let me execute this test. again, creating, inserting, and if I go here and I say select all from item, I will say item from JPA to Hibernate. So what I demonstrated here is the usage of the JPA API and the usage of the Hibernate API, and how to switch between them, how to unwrap a session factory from an entity manager factory, and how to build an entity manager factory from the Hibernate configuration. Otherwise, I emphasize the fact that JPA and Hibernate have some similarities into the API. You have to create some factory object, then some object from the factory, begin transaction, persist or save the object, commit the transaction, and things of this kind. Do we have another alternative? Yes, we do, with some advantages and also with things that we need to know about Spring Data JPA. What is Spring Data JPA? It is another layer that comes on top of JPA. So it is managing repositories. And what I'm telling here is, by creating this interface item repository, I am telling that I am managing entities of type item having a key of type long, and if I go here into this entity item, I will see, yes, it has, remember, this long key. Let's have a look at this CRUD repository. It is an interface. It is an interface belonging to this org Spring Framework data repository package. It comes with some methods. And if I go here, I see that it extends repository. I go here and I see, okay, nothing here. But I have some methods, and I'll go back to these methods. Let's see what we are doing with this item repository. I go here to this item Spring Data JPA test, and what do we have to tell here? We have a much shorter piece of code. Yes, if I compare it with this one, you see it's much longer, and not only that it is much longer, but you also have to deal by yourself with a few things. You have to create all these objects and to manage the transactions. While here, if I have a look here, okay, I create and set the object, and then I say save. Where does this method come from? Yes, it is inherited from CRUD repository. And if you ask yourself which is the implementation of this save method, I would say yes, this is a question that will answer to it, which is the implementation of this save method. You see, I don't have here to manage by myself any transaction. This is provided by Spring Data JPA. And what am I doing? How am I obtaining this item repository? I am injecting here through the Spring auto-wired annotation, and Spring will create an object of this type item repository and will inject it here, and we'll see exactly what this item repository is. What else do I need to know in order to correctly execute this test, I need to extend my test with this Spring extension. In fact, this is a JUnit 5 test, and this extend with annotation belongs to JUnit 5, and the JUnit 5 extend with receives this Spring extension class as argument. Also, what else do I need to know? I need to provide some configuration, just the way I was providing configuration for Hibernate and for JPA, and this time I am providing the configuration with Spring Data configuration. What do I see here? I have some similar information as I was having in the case of Hibernate, and in the case of JPA, I'm providing the driver, the URL, username, and password. But you see here, I am annotating a few methods as bean, annotated with this @bean. What does it mean? It means that Spring will be able to create beans returned here, bean returned here, and to use them for the configuration or for injecting them in our application. What else is interesting here to notice? I am having this Jpa Transaction Manager. So we are still having some transaction, but we do not manage these transactions manually. Remember here, for example, for the case of JPA, I had to create entity manager and to begin transaction. While here, for item Hibernate test, I had to create session factory, then session, and then to begin transaction explicitly, programmatically by myself. While with Spring and with Spring Data, the management of transaction is handled by this Jpa Transaction Manager. Just by the fact that it exists, we have a bean of this type, Jpa Transaction Manager. And we also need some information and some beans about JPA vendor adapter, meaning what type of database you are using. It is MySQL this time. And about this local container entity manager factory bean. Also, you see some information about properties, about configuration in a similar way with what we are providing for JPA and Hibernate, but this time as beans. You may ask yourself, can we do this with XML configuration? Yes, we can. We can create beans with the help of XML configuration, but I chose to do it with Java code for a few reasons. One thing is that it is easier to refactor Java code. You can easily refactor it with the help of the IDE. Plus, nowadays, XML is less in use in Spring applications, and this configuration, Java configuration, is more predominant. We see here that I annotated this class with enable JPA repositories. What I'm telling here, if you need some repository, and we are going to go back to this idea of repository, please have a look into this com manning twitch orm repositories package, and you will find this item repository. So yes, it is here. We say enable JPA, look for repositories there. You will find this interface here, and you are going to inject such a bean here, and we'll have a closer look at it. Let's execute this test. We haven't executed it yet. Okay, just a moment. Save retrieve item. Okay. And if I go here, I will see item from Spring Data JPA. I modified the information from here in order to differentiate between these items and to be sure that we are executing the right test and successfully. Now, I was raising a problem about this item repository. I was saying that it extends this CRUD repository and it comes with these methods. What do these methods do, and which is the real class of this item repository? And here we have to discuss about the Spring Data JPA proxy mechanism. What does it mean? It means that you have your class that is created effectively at runtime by Spring Data as a proxy class. Proxy means substitute. So you remember that we have our item repository that is extending CRUD repository. And when we are auto-wiring it, we are going to see that Spring Data, in fact, will create such a proxy class that implements item repository and will create all those methods. All those methods will be created automatically by Spring Data. So you don't have to care about the implementation. You say, I have an item repository. Yes. What is it? It is a CRUD repository. So you will be able to save all, find by ID, and do a few common things that are provided as a gift from the side of the Spring Data JPA. And if you would like to see what's the actual class of item repository, let's have a look here. I will print it. In order to make sure that it is a proxy class, just like I was demonstrating here. Let's have a look here. You see, we printed here the name of the class, and this is a dynamic proxy class created by Spring Data at runtime. So these are the mechanisms that help us shorten the code. And something more. Let me close a little these things. I go here and I say, yes, I do have this item repository. What else can I do with it? Just to extend this CRUD repository, maybe I need something more. And I may say, okay, let's create a new method. Find by info, and I will provide here some info. And if I go here inside the test, and instead of writing find all here. I will say find by info, and I will say here item from Spring Data JPA, exactly the information that I inserted. Let me re-execute the test. I replaced find all with find by info. Okay, it still prints this proxy class, but you see that I just declared this method. I provided no implementation, and it is able to find the items having this information item from Spring Data JPA. Why? Because this proxy created class has this method automatically created. How? Based on the name. When I say find by info, it will parse this name and we say, okay, I have to create a select to select the items by info, and I will pass this parameter and I will get it. So let me just add here some info that does not exist, and I will try to retrieve it. The test fails because there is no item with such an information available. We demonstrated that yes, our test is really working fine. No, we did not receive one item but 0 items. So Spring Data is able to dynamically create methods of this type just by parsing the name. And this is the beauty of Spring Data, that you just have to write a few lines and it will generate all the code for you, and you will be able to be based on these repositories, and everything will be automatically created. It will greatly shorten the code, and of course it will greatly shorten the development speed. There are of course a series of conventions about how to name these methods in order to really execute something. We'll not dive into this, but just to emphasize here that find by info will translate in select all from item, where info is this parameter from here. So far so good, but we may ask ourselves, does everything come only with advantages? No drawback, no shortcoming from the side of Spring Data JPA. Remember, it sits on top of Hibernate and Jpa. So it is another layer of indirection. So if you address to your database, you have to pass now through another layer of indirection. So we have some natural question. How do we perform? How is the performance of our program accessing the database? And in order to measure this, I created some small tests here. This is some variation of the program that we just demonstrated, with the difference that will build a list of items, of a number of items, and will decide dynamically through configuration how many items we would like to use, and we will save, update, retrieve, and delete these items, and we'll make some simple measurements of the time that this needs to be executed. If we have a look here, we build this items list. Get iterations as provides this property. It is here. So let's try to do this, meaning to save, update, retrieve, delete. How many items? 1,000 items this time. And measure the performance. So you see, we have just a moment, please. Have here the performance, 2180 milliseconds for insertions, and this is for update, for retrieve, and for delete. Let's do the same thing for JPA. We have also a Jpa Performance Test, and I have here this configuration also with 1000 rows. And of course, we are doing the same: save, update, retrieve, delete. And we will look at the performance. 2 seconds. Let's compare for the moment Jpa and Hibernate. So 2100, 1500. If I go here, 2180, 1339. Pretty similar. Let's have a look at Spring Data Performance Test doing the same thing with the same 1000 items: store, update, retrieve, delete. Okay, just a moment. All right, we see the first times here, 4000 milliseconds. You'll see that we have some different thing here. About double the time for insertion, more than double for update, and also considerable differences for retrieving and deleting. So Spring Data comes with some serious overhead, and this is just for 1000 records, because I changed the numbers and I made some variations here from 1000, 5000, 10,000, 20,000, 30, 40, 50,000. And you see here the graphics. Of course, the time is increasing as we are having more records, but Hibernate and Jpa have graphics that almost overlap, while you see how the variation in the time of the Spring Data is. So if you would like to insert 50,000 records, you will need about 1 minute, while here you will need about 17, 18 seconds. And the same phenomenon for update execution time. And what it is interesting and is remarkable is that the update execution time is higher for Spring Data than the insert execution time, and the same you'll see for deleting. much higher for updating and deleting than for inserting, while for Hibernate and JPA we have smaller time for deleting and for updating than for inserting. Also, the retrieve execution times vary. You see here that it is slowly growing, while for Spring Data JPA it is growing much quicker. So Spring Data comes with really nice features and advantages. We emphasize them here about the shortage of code, but it has some serious additional overhead or some performance penalty. And if we look more here at a few things just to tell about them. Here for Hibernate, I needed to add here this dependency, Hibernate dependency. And if I take a look here at this Maven tab here, I see, okay, I have these dependencies, and behind this dependencies I have some transitive dependencies. For JPA we have something similar. If we look here in POM XML, I have one dependency, this one, and the effective jar files that are here are pretty similar. While for Spring Data, okay, one thing is that I have one and two dependencies here, third dependency here. Okay, that's not a big deal, but here you add more transitive dependencies. So you have more classes on the class path, more jars added to your class path. This means a higher memory footprint. So just to be aware of the fact that Spring Data doesn't come just as a gift, but it also comes with these shortcomings. And if you will ask yourself, okay, in this case, should I use Spring Data? I will definitely answer in most cases yes. In most cases yes, and for the good reasons are that the advantages are really high, and if you really face some shortcomings, you may decide just for those situations to avoid it. The advantages are really high in the sense that it really shortens the code and the development speed. Nowadays it is easier to buy some more computing power than to buy some programming force. Plus, the fact is that in most cases your application most likely will not save, update, delete batches of records. And if you most likely will save, update, delete a few records, that performance penalty will be much less. Otherwise, I am sure that the developers of Spring Data JPA will also take care in the near future about this performance penalty and improving this overhead. But this is how the situation looks like now, both from the point of view of how easy we can write our code and which shortcomings we may face. So this concludes our session. We have introduced briefly the work with Hibernate, the work with JPA, and the work with Spring Data JPA. We have compared and contrasted these alternatives, and we demonstrated which are the advantages and which are the shortcomings of each of them. Thanks for your attention. I'm having a look here at the channel, possibly to have maybe have some questions. I will wait 1 more minute. Maybe some questions will pop up. What should I do if the enterprise just work with store procedure? Is there a way to work with ORM? ORM mostly works at the level of objects. So in all our examples, we directly manipulated objects. So you see here, I have item and I am persisting it with Hibernate. With JPA, I have item and I'm persisting it, but with a different API. While here I have item and I'm saving it. So ORM, by its pure concept of object relational mapping, works at the level of objects. If you would like to directly call some store procedures, yes, it is possible, but you will do this also possible with our frameworks, but will no longer work with objects. You will have the possibility, you just have to do some small research on search engine to call a procedure from your program. Yes, it is possible, but in this case you will forget about working with objects. You will just call from your code that stored procedure. It is possible from these frameworks. It is also possible from JDBC, but you will no longer work directly with objects. I say here, I'm addressing to the object, I say save or persist the object. While working with stored procedures, I will call that stored procedure and I will ignore working with objects. I'm still looking if something new appears here. I'll wait 1 more minute. Will the test get more complex with store procedure? No. You will no longer use all the things about creating transactions or using these repositories, but you will just execute the store procedures. Eventually, you may check the result of executing the store procedure just the way we are doing here, to say, give me now all the items from the repository, and I will check here that I have also inserted the items through the store procedure. But there will not be changes in the complexity of the test. Okay, it seems that there are no more questions. Thank you so much for your participation. I think and I hope that this information will be of good use for you. I'm Cătălin Tudose, I'm author at Manning, and see you in the next sessions. Bye bye for now.